Hi, you're welcome to today's tutorial. Today we shall be considering the construction of an epicycloid of a circle having a diameter of 40 millimeters which roll outside another circle of 160 millimeter diameter for one complete revolution. Draw a tangent and a normal to the epicycloid at the point 150 millimeters from the circle. So now the radius of the base circle is 80 millimeters since the diameter is 160 millimeters. The radius of the rolling circle is 20 millimeters since the diameter is 40 millimeters. Some other persons call the rolling circle the generating circle, so which is the same name. Now the rolling circle rolls along the larger circle, which is the epicycloid. Now the locus of that path of the rolling circle is the epicycloid. So that is what we are going to consider today. So now the other thing that we need to consider is the angle of which the rolling circle moves. Now to calculate the angle of the rolling circle, it's going to be the radius of the rolling circle divided by the radius of the base times 360 degrees, which will give us the angle in which the rolling circle rolls along the base circle. Now after calculating this, it will help us to determine the points in which we are going to calculate on the rolling circle once we are given the base circle. Now we start at this point. We have our radius of 80 millimeter. We draw this arc. Then the next thing is to take note of our point. Then we draw a vertical line from the center, which will give us the point where we are going to start. So now after drawing the vertical line, we divide the angle that we got, which is 90 degrees, into 2 to give us 45 degrees. So we have 45 degrees. Construct to the right. We describe the length to the right. Then also we do it to the left with reference to the center. So the 45 plus 45 will give us our 90 degrees of the angle of the rolling circle. So now at this point you extend the line so that it will go out, since we are going to draw our rolling circle outside of this base circle. So that is what we are doing at this point. So we take the other 45 this way. So now after getting this point, our total angle is 90 degrees. So the next thing is we put our compass to get this 20 millimeters. Then we put the center of the compass here again to get our circle, whose radius is 20 millimeters. So now after getting this circle, we're going to divide it into 12 equal parts. Now one of the methods is to use compass to divide it, or we use a protractor to measure the angles. Now 360 divided by 12 is 30 degrees. So now we measure each angle and mark them at the difference of 30 degrees. So that's how we do to get that. Then after that, you connect all your points, which are 12 points, and you mark them starting from 0 to 11. Now we want to get the division along the base circle in which the rolling circle rolls along this path. Now the circumference of the rolling circle, we can use two methods: the division along the circumference or division using protractor. Now this division using protractor, we have 7.5 degrees or using our compass. Now we get it, then we connect it to the central point this way. Connect all the points to the center O of the base circle. Now we've gotten all the 12 points, and remember they are extended out of the base circle. Now we have various points. Now the next thing we're going to do is to get the part in which the center of our rolling circle, the center part of our rolling circle. So now you can see, for emphasis sake, make it red, but for your own sake you can make it much darker so that you can be able to get the actual part. It might be similar to the part for 3 and 9. That's why we need to emphasize this. Now we'll mark all these points to get C1, C2, C up to C12. So now after getting these points, we now start drawing the circle, which is the radius of 20 millimeters. The radius of 20 millimeters. So now the next thing is we are going to extend the lines from the point, each of these division on the rolling circle. Now we've done for that of 6. Now we'll do for that of 5 and 7. We'll project the lines in which it will be rolling. Now we need this line so that we can be able to get the locus of the part of our rolling circle. So now we are at the point for 4 and 8. You repeat the same process for the rest so that we can be able to get the part in which the locus, the circle, rolls. Now with our radius 20 millimeters, we fix it on the center C1. Then we'll now describe the arc on the line for 1. The line 1, we'll describe it there. Then the same radius, we'll move it to C2. We describe on the line 2. Then we repeat the same process also for C3 up to C12, so that we can be able to get where the circle is touching the line as it is moving along that path outside the base circle. Now we've gotten all of our 12 points. Now start marking each of those points. I have to mark them so that I'll get my accurate required point when I'm connecting my lines. So after marking this point, I'll not connect them using my French curve or any of the flexible material that I need to connect this point. Now we've gotten our locus along this path, which is the epicycloid. Now the remaining part of the question says draw a tangent and a normal at point 115. So it means we're going to pick a radius from the center of our base circle, 115 millimeters from the center of the base circle or directing cycle. So we'll mark it on the epicycloid, on the locus. Now I'm going to use green color for emphasis sake. We're using this green color so that we can get this point. So now we are going to describe that point so that we can be able to bring out the required tangent and the normal. the green color just for emphasis. We've gotten our 115 millimeter radius. So we describe this point. So we label it D. We label this point D. Now I'm going to pick the radius 20 millimeter to mark the part of the center. That's the part for the C1, C2 up to C12. That line we're going to mark there with the radius 20 millimeter. We'll mark at that point to get E. Now after getting the point E, we now connect E to the center of the base circle. A straight line passing through E to the center of the base circle O. So we draw that line and connect it. Now after drawing this line, the point where the line meets the circumference of the base circle, we call that point F. We call that point F. So that point F is the required point that we need to connect to the point D, so that it will give us our normal. So from that point F, we connect to the point D so that we can get our normal. So after drawing this line, at the point where this normal meets the point D, at the point D we are going to construct the angle of 90 there. At the point D, construct angle 90 there. This way we describe this arc, then we describe the other arc so that we can be able to get angle of 90 degrees. So after getting that angle, then we make sure we connect the line through D, and make sure the line should pass through D and extend it. So that line that is constructed here is the tangent. So now after this, we are done describing, we connect the line from this point. So this is our tangent. Thank you for watching today's tutorial. Hope you understood it. If you have any comments or question, you can write below. Thank you.